All right, so let's do 7 through 11 here together. These are all simplifying the exponential expressions using those properties or those rules of exponents. So the first we're multiplying. So I'm going to multiply my constants together. Negative 6 times 8. That's a negative 48. And then for x, I'm going to multiply these powers of x together. X to the 4th times x to the 7th. I'll write that here. I'll write negative 6 times negative 8. Negative 6 times positive 8. That's negative 48. Here I'm going to add these exponents. When I'm multiplying with the same base, I'll add these exponents together. So this becomes x to the 4 plus 7 is 11th power. That's number 7. Negative 48, multiply here. X to the 11th power. Now when I'm dividing with the same base, I'll be subtracting these exponents. Multiplying, same base, you add the exponents. Dividing with the same base, subtract them. So 20 divided by 4, that's 5. The new power for x is 9 minus 4, which is 5. The new power for y is 11 minus 3, which is 8. The new power for z is 9 minus 8, which is 1, which I don't need to write. There we go. So now I have a slightly different problem here. Now I'm raising this entire expression, everything in these parentheses here, to the 0 power. Now the property says any expression, any term raised to the 0 power is equal to 1. Even if I have 5b raised to the 0 power, it's still 1. Even if I have 25x to the 13th y to the 6th over 5x to the 3rd y to the 3rd raised to the 0 power, still 1. I can raise a term, an expression with 57 factors or 57 terms if I'm adding or subtracting. Anything I raise to the 0 power, 1, except 0 to the 0 power, but whatever. Okay. So now here I'm multiplying. Number 10 it's like number 7, but with some negative exponents thrown in there. But I'm doing the exact same thing. Negative 5 times 2, I'll write that. Negative 5 times 2, x to the 5th times x to the negative 1, and then y to the negative 6 times y. I can do that because I'm multiplying everything here. That's called the commutative property. I can move these terms around and multiply them together. So negative 5 times 2, that's negative 10. My new power for x is 5 and negative 1, or 5 minus 1, that's 4. My new power for y is negative 6 plus 1, which is negative 5. Now you might think this is your final solution, but you can't have any negative exponents in your final answer. No negative exponents in your final answer. So what's going to happen here is that term with the negative exponent, this y term with the negative exponent, we're moving that to the denominator. Negative exponent, move it on down. Or if it was in the denominator with a negative exponent, I'd move it on up to the numerator. All right, so we're following the same idea we did in number 8 for number 11. 21 divided by 7 is 3. X to the 13 minus 12 is x to the 1st, just 1. And my new power for y, let me show this over here. Y, we're doing the numerator minus the denominator. So that's 13 minus negative 10, which becomes 13 plus 10, or y to the 23rd power. So we've got to be careful with that negative in the denominator there. That can get you. Or if you're thinking about moving, if you move this term that has a negative exponent up to the numerator, you'll have y to the 13th times y to the 10th. And you add the exponents and get 23 anyway. So you'll end up with the same thing. There's a couple of different ways you can approach these. You can start in different places as long as you follow those properties that you have.